All right. Okay. You guys ready?
Yes,
Yes.
sir.
Yes.
Okay, I can start.
Okay. Mute.
Okay, your demonstration very clear. So Daniel, can you tell me what is the difference in laminar and turbulence flow?
Is different. Lamina has minimal electronal mixing, while turbulent flow has high electronal mixing.
And then?
Lamina has parallel layer, while turbulent has disruption between layers. And no, my bad. Lamina has parallel layer, while turbulent flow not flowing in parallel layer. Lamina has no disruption between layer, while turbulent flow has disruption between layers.
Okay. So Michelle, can you tell me in the injection of the dye, how fast you inject the dye? Are you injecting it like you press it once and then you let go?
Yes, sir. It was slowly with a constant speed.
So you don't just press one time and then let go?
No.
So it is not like normal injection by the doctor for the medicine. It's like you continuously flow in the dye.
Yes.
What is the reason that you do that?
To see the movement of the laminar flow.
Again, can you tell me again?
To see the movement, so that we can see the movement of the laminar flow. If
we use injection, like we call it pulse injection,
yes,
we cannot see laminar flow.
The dye is not enough. We have to constantly push it so that it moves like along with the water.
Okay, because if you use pulse injection, then the dye will move out of the system already.
Yes.
So we cannot see it. Okay, can we go to data?
Data. Okay. Clear.
Who is presenting?
Sorry. Okay, so this is the data for laminar flow. The volume of for each experiment we conduct 3 times. The volume all constant, while the time taken from the data is different, and this is the flow rate that we calculate from the experiment, and the flow rate Q with m cube per second, and this is the result for Reynolds number. And this is for the transitional flow. The explanation is the same, just like the laminar flow with the data. And turbulent flow is also the same.
Daniel, how do we calculate flow rate?
We divide the time, not the time, the volume will divide times.
Okay, how do we calculate Reynolds number?
Formula.
Clear? Slide 5, please. So this is the formula to calculate Reynolds number.
UD divided by V.
Yes.
Okay, one question for all. I let you think first. Kinematic viscosity. What is the difference between kinematic viscosity and viscosity? Okay, you think first, later you answer me. We'll go back to the previous slide. Oh, you finished experiment 1 already. Now we go experiment 2. You continue present experiment 2.
Okay, so this is the data for experiment 2. The first table is for lower critical point. This data is from lamina changing to transitional flow. The explanation for the table for the data is the same, just like the rest of the data that I have presented. And the second one is turbulent flow.
I think the second one should be higher critical point.
It's higher, sir. Typo. I just realized that it's higher critical point.
Okay. Marina, what is the purpose of experiment 2? It looks same like experiment 1. Marina, are you there?
Yes. Wait.
Well, Marina is thinking. Any answer for the viscosity, kinematic viscosity? Anyone?
Oh, wait, sir.
What is the difference between kinematic viscosity and viscosity?
Wait, sir. Okay, viscosity gives the information of the force needed to make the fluid flow at a certain rate, while the kinematic viscosity we can tell it about how fast the fluid is flowing when the certain force is applied. Sir.
So in terms of mathematics equation, so kinematic viscosity is viscosity divided by the density.
Oh, yes, sir. The mu divided by density.
Okay, so the mu is actually called dynamic viscosity lah.
Yes.
That viscosity is the normal viscosity that we know. Then they come up with one kinematic viscosity because they divide it with density. Okay, Marina, you have the answer already? Others can help?
Not yet, sir.
What's my question just now? The purpose of experiment 2 kan?
Purpose of
Anyone
Yes.
can answer for her? What is the purpose of experiment 2?
critical point transitional the surface tension kah?
To illustrate laminar, transitional, and fully turbulent flow in the pipe, and to determine the condition for each flow. To
What is
determine the region,
what is the difference between experiment 1 and 2?
The changing the velocity kah?
I think you answer correctly, but you have to like answer again.
Answer again.
to determine the condition for each flow.
That is experiment 1 kan?
From
Experiment 2?
is the changing
Something with the critical point?
is it to find
Is
so
it
is it
to-
to find the flow in the laminar changing into the transitional flow?
So to find the boundary condition, to find the critical point where the flow type change.
Change, yes.
There is experiment 2. Experiment 1 is they find the middle value of they find the safe Reynolds number that is surely laminar. But the experiment 2, we want to find the critical number. After this number, it will change already. So we want to find the boundary condition, the boundary value lah.
Okay, so
Okay, but if you look at the text there, next slide,
next slide,
slide 5, slide number 5.
5.
Okay, this one, it says lamina is 2001 and below, but your lower critical point, slide number 4, it shows that it is 1001 to 1003, the Reynolds numbers.
So under that is
There is a, what do we call this, a difference between this statement and your experiment data. We call it the difference, like the difference between theory and the data lah, practical. Any idea why got this kind of difference?
probably because they didn't measure it right way, sir.
They have errors, they could have errors, but it's not of the measurement, but it's because they don't know when is the actually got changes from laminar to transition. Okay, because it is quite confusing that you cannot be sure that when is the point that laminar change to transition. That's why you can see the range of transition is quite big. They are not sure. If you look at the diagram also, transition and turbulence, sometimes you cannot really differentiate. But laminar, of course, we know because it's very, very straight line. Okay, so you can say that the error is with the experimentalist, or the text written there, or the theory written there could be wrong also. Could be not fitting our condition because we are using water, and perhaps the temperature is not the same, perhaps the fluid is not the same. So error could be at both sides lah. Okay, if you look at the transition flow and the turbulent flow here, we can say that it's like the same. Not very distinctive difference lah. But the laminar flow very clear.
Yes.
Okay, that's all for your group. That's all lah. No more fluid with me, no more with me. But with Dr. Jufri still have. Okay, so please go and key in the attendance, key in the link for today's presentation. And I guess you don't have to see me for the remaining semester already. That's all for Fluid Lab. So I wish you Happy New Year lah, and enjoy your remaining semester.
Thank you, sir.
Okay, sir. Thank you.
Thank you, sir.
And Happy New Year, sir.
Happy New Year,
Alright.
sir.
Happy
We'll meet
New
again,
Year
sir,
too.
in campus.
All right.
All the info.
Bye.